Hi everyone, I'm really excited to interview Pedro Veloso, studio instructor at Carnegie Mellon University. He's a computational designer and architect interested in the intersection about artificial intelligence and design. His research interests include cybernetics, classical AI, bio-inspired AI, agent-based modeling, and machine learning for design exploration. Currently, he is investigating the application of AI in early spatial exploration, such as in the architectural composition and spatial planning. In this interview, you will get to know about Pedro's journey, his research work, thoughts on application of AI in architecture, along with advice to young engineers and students who wish to do similar work. I have seen the work of Pedro on CRAIDL website, and they are doing some amazing research work. And I haven't seen such research work AI in architecture among other colleges. So I'm really excited for this interview. Hi, Pedro.
Hi, I'm really excited too.
Yeah. So Pedro, can you tell us about your background, where you grew up, and out of all things you could do in life, why you chose architecture?
Okay, I think you can see on my background here, I'm from Brasilia, the plant capital of Brazil. I lived in other cities, but I ended up like returning to do my high school and college in Brasilia. And I studied architecture and urbanism. That's like one major in Brasilia. I mean, I think I enjoyed architecture because of Brasilia. That was for sure because I lived in a place that was like designed by architects. And but I also enjoyed visual arts. I enjoyed like sci-fi movies, comics, and I was really into like illustration. I was a decent slash like good artist, visual artist. But at the same time, I liked like mathematics, geometry. I was curious about programming. I thought about like maybe I want to create video games. So I had all like these ideas, and I thought that architecture would be like a good territory to conciliate my different interests. Yeah, I think that would be my motivation.
Throughout your journey when you're studying and researching about architecture, how was the philosophy evolved through time, and what are some core components of your design philosophy?
I think I'm particularly interested in design methods. So I like to see design as like a form of strategy that aims at changing our environment and influencing our experiences according to our values and positions. So in this sense, I think design comprehends like different tactics. So you have like traditionally in architecture, you have like design by drawing. You can do research in typology or precedence. You can use diagramming. You can use like argumentation. You can think about conversations, collaborations. There are so many strategies, and now we have like a whole set of like computational strategies with their own limits and potential. So that's like I think that's kind of a synthesis of my design position philosophy. And in terms of my, let's say, the highlights from my education, I think both my education as an architect in undergrad and master's, like I did my undergrad at the University of Brasilia and my master at the University of São Paulo. They were very influenced by a combination of like more like intuitive design with like the formal tradition of Brazilian modernism. So as far as I remember, there was no like programming in the curriculum. Even CAD tools, like if there are some professors that they will consider CAD tools very disruptive. So if you think like my early interests in moving beyond that tradition, developing like custom non-standard adaptive geometry relied on very time-consuming workflows. I was not using programming at the time. Like parametric modeling was not like a thing. So at the same time, my workflows are very time-consuming, and the results are not typically well received by the status quo. So in a sense, I'll say that this kind of like motivated me to look outside of conventional architecture education. So I think that was my starting point. And the turning point of my career, I think when I was living, I was doing my master in São Paulo. So I was living in São Paulo around like 10, 12 years ago. And I met researchers with similar interests, such as Professor Gabriela Celani, Gonzalo Henrique, and Ernesto Bueno. And with them, I not only discovered like programming and parametric modeling, but also the field of design methods and computation design. That was a really important moment for me. but also I'm very curious. So it's like I discovered the field, but I also started investigating like things like cybernetics, classic AI, and I was like fascinated to understand computation, like not only as like an alternative logic for design or a method for exploring like non-standard geometry, but potentially as a way to encode control and rational decision making. That's where I started to be interested in design automation, co-creation, human computer collaborations. And that's when I decided to start a PhD at CMU. That's a Center of AI Research and Education.
That's quite interesting because like I come from India, I'm currently studying in US. So a lot of times in the education in those kind of countries don't have like a technological adaptive curriculum. And when you come here, you see everyone doing
Yeah.
like coding and a lot of tech. So w- was there like a point where you decided, oh my God, I need to pace up my my learning and research in technological area to match up to my peers or something?
Yeah, I think that moment was at like the second half of my master and then a transition to the PhD because I was learning by myself, like how a little bit about AI programming. I was learning all these things, but then I started my PhD. And again, when you come to CMU, like undergrad students are coding, they are doing like some of them doing machine learning, and you're like, okay, I need to pace up. I need to like I knew a lot, like, but from in a practical level, like, oh, you need to know how to code this, you need to know how to like put your hands on and do this. So I had to pace up and like catch up with all these things.
And like one interesting like pattern I see among people is people who are very curious to learn, they have internal motivation and then they can stretch for long hours and learn quite fast. So moving on, can you share us like how does a day in your life look like? You are doing research, you are teaching, you're
Okay, so I'll start like with a list of main activities there's sometimes a part of my routine, and then I'll be specific and I'll tell you what I'm doing right now. So generally I'm involved in like co-teaching a computational design course at CMU, or recently also a studio. I'm also working collaboratively with my colleagues from CRAID or from other institutions. Sometimes I'm writing papers or articles, reviewing papers for conferences and journals. Sometimes I'm informally sharing ideas or advising students with similar interests. I'm looking for topics, I'm studying topics that I'm interested in. I'm thinking about future research steps. And last but not least, this is what I should be doing mostly. I'm implementing research prototypes for my PhD research. And so in general, like there are a lot of things to do, but I like to have like a structured schedule. So I tend to select like 2, 3 activities per day or something more structured to concentrate. So right now I'm focusing on teaching. I'm teaching the generative systems course, and I'm developing my research prototypes. But often there are like articles, paper reviews, and meetings.
personally, like I have faced that a lot of new research work comes day to day basis on computer science field in the field of AI. And if someone needs to be up to date with that tech, it requires like a lot of reading and also talking with your colleagues. I saw the content of your generative system course and it was quite updated and it has some new systems and algorithms. So how do you keep up to date with the progress?
Yeah, I completely agree. I think it's very challenging. I mean, I co-created that course with that intention. I think we are studying like architecture, engineering, some form of computational design, and I think there are many techniques out there. So at the same time, we need to look back. Like we need to look like decades ago, where people were developing like algorithms. They are think about how to solve problems, and we have like a whole like body of knowledge that we need to learn about it. So I've been investing a lot of time in like looking like to the past, collecting algorithms, ideas. I've been creating a taxonomy to try to organize that, and at the same time you need to look to the present and to the future and see like what's happening now. So I think that course has been like a huge effort to bring all these things together in like a common taxonomy that it will be published soon, and organizing that knowledge in a way that's it's practical in the sense that a designer or a computational designer can like start studying, seeing like the different categories, the different components of generative systems, how you can combine them, and looking for similarities. So I think my whole effort has been to organizing all this knowledge and trying to keep up to date. And I think that's why that course has been very, very important for me.
I know you mentioned earlier about your interest grew during your masters about cybernetics, classical AI. Was there any like defining moment where you realized, oh, machine learning could be a game changer in AEC, or it was a very gradual flow?
I think like when I before my PhD, I was interested in AI, but I think that I knew more about like classical AI. I think heuristic search, you have like classical AI techniques that are very useful. I think I started to be aware of machine learning when I started my PhD at CMU. I remember, I think I took a course in AI. I might get the dates wrong, but that's fine. I'll try my best here. I think in 2016, so it has been a while. I was taking a course in AI, and I learned about deep neural networks. And I think it's important to remember that what's the date of the big like boom of deep learning? I think it's 2012, and I was taking my course in 2016. So you think, okay, so everyone knows about machine learning, but it's not that simple. Like I think before 2014, 16, that's when like all the things we're talking about now, GANs, DQN, AlphaGo, they're being developed and published. And even like frameworks and libraries like TensorFlow, PyTorch, they're being developed and kind of like released. I knew about machine learning, but it was not very popular in the design community. I think another turning point for me was like I was watching a lecture by Professor Golan Levin at CMU, and he started showing all these examples of like generative models and dimensionality reduction in music, visual arts, and I was like, whoa, there's something happening here. So in that same year, and I think that was my first contact with more like creative AI. And at that point, I was working with more like with agent-based modeling. So I identified in reinforcement learning like the potential to take my research to the next level. And that's when I started taking like specific courses in machine learning, reinforcement learning. Yeah, I think that was the turning point.
Next, I would like to move on to our next section in which we'll get to know about Pedro's professional work and projects. So, can you give us an overview about of your research work till date?
Okay, I've been doing research for, I don't know, maybe 10, 12 years. So it's like I've been involved in many projects. So I'll try to synthesize that. So I think I situate myself in a very like interdisciplinary space between architecture, design theory, computer science, computational intelligence. And I built like a research career in computation design that can be roughly divided in, I think, 4 or 5 areas. So let's say area number one is more or less chronological, but sometimes they overlap. So area number one, I think when I started doing research, I was interested in this relationship between computation, cybernetics, and design theory, where I was more like concentrating on the design theory and design philosophy side. But at the same time, as I mentioned, very curious. So I started interacting with other researchers, and I discovered that in computation design, it's really important to to do like develop like practical applied research. So I also started working on my second area of interest. So we can define it as like parametric design, scripting, fabrication, where I worked more on computational workflows for fabrication, artwork, installation, detailing, building performance, and so on. So that's my second area. The third one, I think that's related to the course that I described it earlier, generative models for design, or generative systems for design, that's the name of the course. So have been working mostly as an educator, developing actually not only the generative systems course, but also other courses in programming, data structures. But I'm mostly interested in a framework that consolidates and organizes the knowledge on the topic so it can become part of a design education, architecture education. So, and often I apply those ideas to my own practice. Okay, we move to the fourth area. So that was my initial interest in my PhD. I was interested in agent-based modeling for spatial design. So I was investigating like physics-based, bio-inspired agents for generation of building circulations or spaces. And I was also addressing like experimental visualization of urban data. Finally, last but not least, I'm currently interested in interactive AI and deep learning for co-creation, where I focus on the creative and fluid interplay between humans and intelligent models for the development of spatial configurations. So most of my research in this area has been on reinforcement learning, autoencoders, and GANs. Reinforcement learning from my PhD research, and there are other techniques in collaborations with researchers from CRAID, such as Ardavan Goli and Jimori. Yeah, so I think that's kind of like an overall review of my research area.
I was looking into your published research papers, and it has some amazing application of reinforcement learning, spatial synthesis in architecture. So it's, if someone is listening and is more interested to go deeper into that research work, you can check out Pedro's research paper. All right. So my next question is, I haven't personally seen groups like Cradle in among universities doing AI research. So can you share like a background story, how it was formed, what are the research area group focus on? Because it's quite challenging to form such group these days.
Yeah, I completely agree. We are all part of the computational design program at Carnegie Mellon. That's part of the School of Architecture. So Cradle emerged from informal research meetings that we organized during the last summer in the pandemic. So like as a group of PhD students that shared similar interests, we took like similar AI courses. We developed projects together in those courses, sometimes outside of those courses, and also with researchers from other departments. So we started to see like the potential for creating a group. And I think Credo is interested in research collaboration and also in design education. We are currently teaching a course on creative deep learning for designers and architects, which is called like Learning Matters. And I think it's kind of the first of its kind. In terms of research areas, the group is interested in collaborative research, in creative AI. And I think the best way to describe like more specifically these areas is to think that the founding members like Ardavan, Jimo, Miguel, and I, we are all designers, architects with solid background in deep learning. And among our expertise, we have like generative design, generative models for machine learning, reinforcement learning, natural language processing, and robotic workflows.
Like it's like you're investigating a lot of different advanced models in the field of deep learning, and how we can use those models in architecture design, like even NLP, RL, GAN, like the those areas are research in its own direction. So it's interesting. And I'm not sure like if it's possible to answer this, like is it like funded, or it's still like just a collaboration and you're looking for?
I think that's uh, I think that's one challenge that we face in the group because the group emerged. We have the support of our professors, advisors for sure. That's really helpful, but it emerged as a group of students, right? So it's like it's hard to get funding when you are part of a group of students too. So right now, this has been a challenge, and I think what we've been trying to do right now is invest on the design education side, so we can work institutionally. So answering your question, I think most of the research we developed, it was maybe like either part of our own PhD, so we can use like other sources of funding, or we just develop like as part of course, like, okay, that's really interesting. We need to develop this right now. It's like we need to develop this very interesting. We can publish this. Yeah, so I think there's not a clear answer there, and I think that's an ongoing challenge for Cradle. That's something that we are working on.
And can you walk us through one of your work in detail? Like, what was your approach, challenge, final output?
So I'll briefly share a set of slides, just mostly to show some interesting images and ideas. So this is like a project like that I like to call an Academy of Spatial Agents. That this is like one of my first prototype for my PhD research. So the idea is that if you think about generative systems for design, the idea is that you have a group of designers that they formulate a generative system. So they bring some design knowledge, expertise, a rationale, and they create like a model that's able to generate design alternatives. So they formulate, someone codes that model, and after that they can interact with that model. So for example, this example has like chairs in the design space. So after the model is developed, they can interact with that model. However, if you think about spatial synthesis, the field that's concerned with developing like spatial configurations, and most of the, let's say, the mainstream techniques, they are like destructive techniques, sometimes optimization based. So in general, you end up with this workflow where the designer provides a certain input and the algorithm computes like maybe the tries to find the best alternative or gives you like 1,000 alternatives. Or the designers can also develop like a set of rules to generate spaces, but that's also challenging. So I've been looking for an alternative way of developing like generative systems for spatial design. And the basic motivation here is that you understand design as a type of dialogue. It's not so much I'll give a problem to my model and it will develop the best solutions. The idea here is that the designers want to collaborate step by step with the generation of the alternatives. So it's more like a dialogue with fine-grained interaction and explore the design space together with the model. And you can bias the search and you can look for local and partial solutions. So I think there are a lot of benefits of this approach. And that's where reinforcement learning comes to play, because you have like agent-based models, but in general, they come from other areas. Like if you think about like, I don't know, swarms, voids, like you have a lot of models, they come from different fields. So it's a little bit challenging to adapt them to say, okay, now I'll take this model and I'll develop a layout, a floor plan. So reinforcement learning, in my research, I use it as a way to, let's say, as a way for designers to create their own like agent-based models. So the designer can create like a reward function, can encode some goals, and using reinforcement learning, they will develop agents that will achieve those goals. So the designer provides like what the agents should be able to achieve, and the agents learn how to do it. That's more or less the explanation. And you can see in the image here, the idea that you have something that's dynamic, that's very interactive, and you can interact and you can change parameters, or you can directly interact with that. Yeah, maybe I could share some lessons for researchers, but I think one first lesson, just like parenthesis here, it's like when you're developing research with reinforcement learning, always start with a simple prototype. It will become more complicated than you expect. Reinforcement learning is not simple. At least today is not simple. So the challenge is like, okay, I'm going to use deep reinforcement learning. So I'm going to use neural networks and I want to train these agents. So how I'm going to represent these agents, how I'm going to represent their actions, how I'm going to represent goals. I think people who are more interested in these details, there are some papers that are published, but I'll briefly show here some images showing like in this prototype, I used like a very, let's say, classical representation that's a grid, because then I can use convolutional neural networks. So I can have like multiple, for the state of the agent, I can have like multiple layers indicating different aspects of the agent, like the goals, the types of cells, the shapes, things that will inform the algorithm, will inform the model. So basically the representation is based on layers with information, and the agents are like polyominoes. So they're sets of cells that share edges, and they have a perception around it, and they take actions basically by expanding or retracting, like select one cell, expand, erase, or add one cell. And that looks very simple, like, okay, so I have this set of cells and it can add one cell, can remove one cell. That looks like too simple. But I think that's the interesting part, like the reinforcement learning model will use those building blocks as a way to create more complex actions. So you have like spaces, each agent here is a space. The space can like reshape, the space can move quickly to another position. So there are a lot of like complex behaviors that emerge out of that. I think that's lesson number 2 here, is that for me, when I look at these grids, I'm very excited. Well, look at these, very interesting how I'm representing like adjacency between spaces and areas. And when the agent starts to learn, that's very exciting. But I need to be aware that my audience is not necessarily made of architect of computational designers interested in reinforcement learning. So in a show, reinforcement learning works with like representations that in general they have like a lower resolution. Like this case looks like probably like I don't remember, like 12, 16 by 16, 12 by 12, very low resolution. So when you show to designers, they're like, all right, that looks like a grid of cells. Like I don't care. So it's hard for designers to understand and to see how the knowledge in terms of behavior is being embedded there. So the challenge is that you also need to develop representations that are specific for your audience. And that's where, when after training, I trained these, you can see the details in the papers, but I trained these agents to try to solve like adjacencies, certain areas and shapes, and the designer can change the parameters of these goals. So I trained these agents, and I'm trying to figure out how to generalize that knowledge, like to, let's say, to novel situations, to design problems. So this is just like an example where I take these agents and I use each of the agents to represent the space in a house. And I establish adjacencies, I establish like the areas. And I release these agents in an environment with obstacles, and I let them develop the kind of like this layout floor plan. And I keep adding, in this case, there's no user interaction. I'm adding noise. So I keep adding noise to see what happens when the agents like, the agent can select actions to try to develop the layout, but at the same time, it randomly selects some actions, some disturbing. So the agent has to figure out another layout. And as you can see, I think I like the part where there's a lot of noise. I think you're going to see it soon. So you have kind of like a layout working on here. Yeah, and then you have noise there, a lot of noise. And then the agents have to recover and find another layout, which is really interesting. But at the same time, you can see that I have a parametric model over the agents. So I have windows, I have walls, I have doors, I have like some areas that are two agents that are considered part of the same space. There are no like divisions. So I have a layer of like geometric entities and control over that. And that's where that last lesson is important. Like when I show these to a designer, the designer can understand, whoa, now we have agents. They're like generating spaces. Look at that area. And I think that's important for researchers. And here at the bottom, you can see like 3 different environments with different obstacles. Some results, you end up generating like completely different layouts, even the layouts with a lot of noise, a lot of randomness. It's kind of like interesting. But this type of model, like this is an image of me talking to Jimo, and we're like, I'm showing to Jimo, this is what I'm doing in my research, take a look at these models. And immediately his reactions, like we are on a Zoom conference, like to start sketching, oh, look at this is interesting. You have like an empty space here. That's very interesting in terms of design. Oh, look at this glass wall. He starts sketching on that. And I think that's important because that's where design happens, when you start like interacting with the models, right? So in this research, I've been trying to integrate learning, agent-based modeling with goal parameters, and parametric modeling. And I think there's a potential for developing custom agents for designers. There's a potential for real-time collaboration. And currently, I'm trying to bring that interaction that I have just mentioned. I'm trying to enable designers to actually interact with the agents using game engines. And I'm also improving the reinforcement learning workflows, and I'm testing different policies and so on. So lesson number 3, this is more for computational design researchers. Like custom code is good, but then whenever you can, use libraries. The reasons, like when your project starts to escalate in terms of complexity, like in my next steps, I'll show a video here. I'm integrating like Unity game engine with parametric modeling, with like a backend in Python, with PyTorch. So you have all these things together. And sometimes you need to test multiple algorithms. So when you work with libraries, that makes your life so much easier. So even though you want to code everything, you want to understand everything, it's good to work with libraries. That's another lesson. And here's some images of my work in progress. I think this is the first time I'm showing these images, these videos actually. So this is more like what happens when you can actually interact with these agents in a game engine, like in real time. You can change like parametrically, you can change the geometry, but you can also grab the agents, change the shape of the agents, and so on in real time. So you can see that you can kind of like, it's more or less like sketching. You can shape your design, you can interact with your model, and the model gives you something back, like trying to satisfy the goals. And you discover, like, what I think is really interesting is, like, instead of thinking about, I'll find the best solution, no, I'm finding multiple solutions where the designer is trying to bias that solution. So I find like partial solutions that are very interesting. They might not have the best scores in terms of like utility functions or whatever, but the designer thinks that's a really good solution. So the designer should be able to find it. So I think this, for me, this is very exciting. So this is what I wanted to share.
This quite interesting work. I was like observing all the work and the research you did. It's amazing work. Can I ask a few questions in this?
Sure.
Yeah, so I did like a reinforcement learning in an hackathon where the problem was how can we optimize resources in AEC about allocation, and the model was doing multiple allocation strategies, and our intent was how can we learn patterns from this RL agents. And one challenge personally I was facing was like how do you determine the reward, how do you find a strategy of like exploitation versus exploration, because like a small difference in those values will make the model more conservative, more exploratory. So
Yeah, my answer, like, I wear my designer hat here, and I'll answer something that's not very like conventional in reinforcement learning. But I think what's really interesting about design is that, in comparison to problems from reinforcement learning, is that we can provide rewards like almost at every state. So if you think about problems in reinforcement learning or even video games, I think there's a big challenge in video games is like, how do they call reward sparsity or something like that? It's like your model is trying to discover good behaviors, but the environment never gives like rewards. So maybe you just get a reward after you finish a certain stage in the video game. So it's really hard for the model start to explore, figure out actions, and get a reward. In design, at least in like in spatial synthesis, this is an area that has been addressed mostly with optimization. So we have it's part of our design culture to understand like, oh, I have a metric to evaluate this arrangement here, like this room, these connections. So I have utility functions, I have heuristics, things that I know that I can encode. So I think it's much easier in reinforcement learning to provide more rewards and also to provide like complementary rewards based on state. So you can have like helping like the reward functions, you can tell like how good that state is. So that in that sense, like every time the agent moves between states, it knows that, oh, I moved from state to a better state. So it's already learning. So it makes, let's say, exploration much easier. So I think that would be one take on that.
I have like a limited knowledge in reinforcement learning, but the from my understanding there are like either discrete or continuous actions you can take, and I assume based on the discussion or the work you shared it was taking like the discrete action, like whether in that grid of cell which action we can take. So it was discrete, right?
Yeah, I mean, this first prototype, I'm working with one that has a like a continuous action space and a continuous like observation space too. But this one is discrete. As I mentioned before, I wanted to start simple. Okay, and but to be honest, like I think the prototype that I'm working with like continuous actions way simpler now. But I thought at the beginning, okay, it's going to be simple. It's a grid. I'll have agents occupying that grid. It's a very powerful representation. Have L shapes, have U shapes, have all these different shapes for rooms. That's awesome. It's very simple. So I started using like very like kind of like consolidated algorithms, and then I'm moving more like to police-based algorithms. So this one I started with a discrete action space and working with like an algorithm that basically works on discrete spaces.
I see. Lastly, can you describe like at very high level what was the process to develop this? So I'm talking like let's say you had a problem of human machine collaborative co-creation, and to define reinforcement model one has to define the environment action space. Like what are some things one needs to make decisions while to develop this kind of models?
You're talking about You're assuming like that I have this research developed and a designer is going to use it, or you're asking me as a researcher what were my challenges when I developed the research itself?
Yeah, as a researcher, like
Okay.
what are some components of reinforcement learning model you had to make decisions?
I think that's an excellent question, because how many researchers do you know that are working reinforcement learning and architecture? You know, like you're probably going to count it like in one hand. And when you work with, for example, other models, think about GANs. Okay, I can take an image of a floor plan. I can take an image of a section. Now you can even take meshes, and you have a lot of people doing these things. So you can look at other researchers and develop them. So when I started developing this prototype, I mean, there was almost like nothing out there. I was like, okay, how do I encode this problem? How do I think about spatial synthesis in reinforcement learning? And it took me a while, like, especially because I'm working, as you can see, I'm working with the multi-agent setting. So it's like, it's even more challenging to think about like, oh, how I'm going to understand each agent. And I came with this idea of what I call like spatial agents. So the idea is like one of the many ways you can represent space, but like the idea is that agents are responsible for shaping spaces. And I think the simpler way is to say each agent is a space. That not necessarily means that you can have like a over the top of that, like in the parametric modeling, you can say these two agents are the same space, but they're going to behave as separate agents. But when they're close together, you only have like walls, maybe walls or glass walls around them. But on the reinforcement learning setting, each agent is a space. And then I started with that, and I say, okay, now that each agent is a space, how does that agent see the world? How does it look around and see, okay, what's around me? What should I do? So, and that's where like I start, okay, let's start again, let's start with something simple. Let's start with basics like spatial synthesis goals, so like adjacency. That's something that since the early days of spatial synthesis, like you're trying to generate floor plans based on adjacencies, areas. And I also added shape. I'm trying to figure out more like rectangular, L-shaped rooms. So I started with that, and I started building this system. So I tried to start with very simple blocks, and I created this concept of spatial agents that helped me figure out a way to formalize all these concepts in reinforcement learning. So again, I was working with agent-based modeling, and I moved to reinforcement learning, but the ideas are similar in the sense that you have an agent, you have an observation for that agent. Reinforcement learning brings the reward, so you can train the agent. And what else? And the reward in this case is based on these standard goals, but you can increment, like potentially you can have here building performance. What about lighting, solar radiation? If you're able to simulate like in real time, the agents can learn how to look for good solutions based on that. So that's like a starting point. So the idea is that if you have a designer, the designer will be able to customize the agents based on custom goals. So you end up creating like custom agents and consequently like custom spaces. So that's the idea.
I have seen a lot of inspiration of RL agents from gaming industry, where like as you were showing, Unity RL is quite accessible these days, and depending on your goal of if you want to have, let's say, your space optimized for building performance and structure, your agents will learn that. So dep- it's important how you decide the goals, so and your agents will be smart accordingly.
Yeah.
I see. Moving on, according to you, what are some roadblocks faced by AEC to adopt AI?
I think this is a hard question. I'll probably focus on my expertise here. I'll focus on architectural design and education. And I think like maybe that's roadblocks is in education in the sense that I think that the architecture schools they're slowly incorporating like computational ideas. I think sometimes probably like research and the industry, sometimes they move faster. So I think it's important to incorporate these ideas in design education. So you can see that now we're talking about like AI, deep learning, but in some architecture schools, even programming is controversial, and some schools have not yet like integrated like parametric design with their design agenda or the education. So I think that's a challenge. And another one is not only on the incorporation of technology itself, but also in the way that we teach design. So if you think about design studios, we typically focus on kind of like designing authorial solutions and visualizations, and we rely mainly on like argumentation between students and kind of a small group of architects as the main form of evaluation and socialization of knowledge. So I design something as a student, I show my instructors, and we discuss if this is good or not. And don't get me wrong, I think it's really important. I think this is an important part of design, but that cannot be kind of like the only source of architectural knowledge. And especially when you think about AI, you need to incorporate like more like evidence, data, you need to incorporate other things. So I think that ideal of like a designer working within like authorial practice, just justified by discourses, is going to become like even rarer as like simulation, kind of like co-creation and automation with AI become like part of like the AEC industry. So I think that the adoption of like artificial intelligence in architecture education, it's something that's it's really important. As a way, it's not purely like the adoption. It's like how you review your methods and your education, considering like that we have access to AI methods, we have access to data, we have access to simulations, and so on.
See, like when you were explaining the feedback from professor, I just had a thought, why not like there would be like a smart agents who can provide instantaneous feedback on your work in future, like so instead of we can remove the lag time and maybe become more productive.
Yeah. Yeah, I think it's a big tendency that, I mean, that's happening. Deep learning has been not only in terms of agents, but if you think about building performance simulations, we are using like neural networks to approximate a lot of things that in the past they'll take like minutes or hours. Now we have in real time. So that's how, as designers, we need to think, okay, how do we design now that we have access in real time to all that information?
I see. What are your thoughts on making AI education for architects more accessible and increase awareness among students?
I think, as I mentioned before, I think that's an urgent task. I feel that the industry and researchers, they have been like very vocal about it, but we need to reach like design education. But again, I think the problems that the schools are still figuring out how to address like basic computational skills in a curriculum that's traditionally structured around studio education. And if we don't change that, what happens is that designers will be restricted to the position of like end users. So you have the industry creating new tools, have researchers developing prototypes, and designers will be like at the end. I mean, and that's an important task, as important part, but I think designers should occupy other territories too. So I think one good step is to incorporate like more like computational AI methods. We should rely more and more on evidence. That doesn't mean that we do not address creativity, but we try to be creative based on evidence, right? So we use data, we try to use more data in studios, we try to use more simulations, and we figure out how we develop like creativity in that context. So we need to create a designer that's able to, we need to like train the designer to be able to kind of like, how can I say, use custom tools, curate data, maybe collaborate with generative models, collaborate with experts in design technology, and has the ability, especially the ability to investigate, curate data, and customize like software. I think that needs to be part of the education of the designers. And for those who are more interested in computation, I think this is like a basic level. People should have some expertise in a way that you can customize your own like workflow. But if you have designers that are more computationally, it's important that they engage in the ideas and even in the implementations under the hood of software application. So we have designers being part of the development of our kind of like technological infrastructure. So I think overall it's not only about teaching programming or generative design, but also like promoting like a new creative practices and understanding how to assimilate design technology and reassess like the role of the designer.
It's interesting. And like a lot of models are available to experiment on GitHub or Colab if someone is getting started. But if it's important that how to curate data set, how to do data processing. I think if if we can do more awareness, then maybe we can exploit the potential of AI models better.
Yeah, I think it's great. I think one thing that as designers we need to improve is like how to, we produce a lot of data when we design, but we don't store it. We save like portfolios, we save like visualizations of files, but like we do a lot of things. What if we save those steps, those actions, those partial representations? Maybe we can use that in the future.
Yeah, that's a good advice. And moving on, like, what are your advice, like, to students or professionals who are just getting started and want to do some research work as you are doing?
Okay, I think there's a lot to be said here, but I'll try to concentrate my answers like on like few suggestions. I'm generally interested in investigating computational approaches to kind of like design problems, and my current work comprehends real-time and interactive workflows with AI. For this type of work, I recommend combining like generative design with some source of design knowledge, such as building performance or spatial analysis, and also having like fundamental knowledge, computational knowledge in programming, data structures. And in this package here, I think generative design is important because it allows students and professionals to have like a wider understanding of computational methods, such as like rule-based modeling, heuristic search, agent-based modeling, parametric modeling, design optimization. So you can start seeing all these things as like part of your method. And you can start bringing data structures, ideas from programming, ideas from AI. So I think generative design is a good core. And in this setting, I think deep learning becomes like a layer. So it's a layer of generative design. So where you use like function approximators to learn some component of your generative system. It can be the generator, can be something that's evaluating your designs, can be the simulation itself. And I think that's very powerful because deep learning allows designers to develop systems that can evaluate design information or generate design alternatives without like formulating them directly or explicitly. So if you think about conventional systems, rule-based models, I think about shape grammars. You need like someone that understands about shape grammars, that's going to develop a certain grammar, a certain language to develop certain designs of certain types of designs. With deep learning, you don't need to do that. You just need data about that design, or maybe you just need, in the case of reinforcement learning, goals that will take to that type of design. So I think it's really powerful. It somehow bridges like intuition and generative design. On the technical side, I think it's important to know these days. It's important to know Python for sure. I would say like Python, C# are like the two main languages. Maybe you learn like one or two more. Of course, it's always good to learn more, but we have limited time, so one or two more, I think is enough. And try to take courses in more specific computational areas such as computer graphics, AI, machine learning, reinforcement learning. And if you don't have the time or access to these courses, make sure you feel comfortable with like basic concepts and with libraries. That's really important to like download, play with libraries for scientific programming, computational geometry, computer vision, optimization, machine learning. And finally, I think beyond like, let's say like the toolbox or the tools of the trade, like geometric modeling, parametric modeling, and BIM, it's important to be versatile and have some expertise in maybe like in animation software, game engines, I think are becoming really important. And always try to use visual programming and scripting side software, and also try to discover what plugins, libraries are available so you can create the right workflow. So I think that would be like a general advice.
Any other thoughts which you wanted to share in this interview, which we couldn't cover in other questions?
I think Cradle and myself, like and I, we are very like, we're kind of like optimistic about the current state of like design technology, and it's a good time to be a designer, could to be a design technologist. You always need to be like critical about the workflows, the results of your designs and all that, but also I think it's really important these days, if you're developing courses, if you're developing your own work in this area, what I think is critical is like you need like to do something that's hands-on. Even if you want to be someone that's going to only like criticize, analyze the work in this area, it's important to learn programming, at least experiment with machine learning, understand a little bit, to actually have knowledge about it and criticize. But in general, for practitioners, for sure, like you need to be good at design, you need to be good at programming, you need to know some machine learning, because I think the message here is like, to be creative, you need to create your own workflows, right? You cannot depend on other people, on other libraries, only other like software. You need, as a designer, you need to build your workflows, and to do that, you need to understand about design technology, right? To different levels for different designers. So I think the message that it's a very exciting time to be a designer, and also it's really important to understand that design technology is not something that happens in a lab. It's part of design. It's something that's going to change how you design. It's part of like design methods. So try not to see these as something that's isolated from creativity. This is also part of how you can be creative.
I see. And I think maybe if you have time, we can do like part two with the whole group, some interview like more technical.
Oh, that'd be
But
awesome.
yeah, that would be awesome. And lastly, how can our listeners follow you and your work?
Okay, I'm not good with social media. I'm still like, I think I'll probably develop or release my website in the next step of my career. So right now, if you want to follow my work, if you want to be in touch with me, follow me on ResearchGate and LinkedIn. I think these are the best channels to be in touch. I try to answer as fast as I can, and I'm happy to share like ideas, share knowledge, and that I'm always excited to discuss these topics.
Amazing, amazing. Thanks a lot, Pedro, for your time. I
Thanks,
had
man.
like so much insights about your work, and it's you and your group are doing some incredible work.
Thank you.